about logarithmic equations, we will practice first with simple logarithmic equations we can solve. So what is the basic thing to do when you're solving logarithmic function? It's only expressing it first to exponential function, because by definition, the inverse of a logarithmic function is an exponential function. So I told you, if you cannot solve a logarithm by itself, you can solve it by means of exponential function, okay? By changing it to exponential. So let's say you really don't know that the exponent of 5 base 2 is base 5, the exponent of 5 is 2 to get 25. So to express this in exponential form, so we have 5 raised to y equals 25. So that's the exponent form of logarithm of 25 base 5 equals y. So we would like to express 25 as base 5, so that because by principle, if the base are equal, the exponents are equal too. So 25 is 5 times 5. So therefore, 25 is just 5 squared. And 5 raised to y equals 5 squared. So you can cancel 5, so y equals 2. Or you can think it like this. It doesn't have to be really specific and detailed like this. You just have to think of what should be the exponent of 5 to get 25, and it's actually 2. Okay, now we'll go to the next one. So to solve this equation, first is to express it in exponential form. So that's 3 raised to y is equal to 1. Okay, and therefore, we are trying to find the exponent of y, the exponent of 3 to get 1. And by principle, we know that any number raised to 0 is 1. So 1 is just the same as 3 raised to 0. So therefore, our value of y is equal to 0. So the exponent of 3 to get 1 is just 0. Okay? Same thing here on number 3. So to express this, to solve it, change it first to exponential. That's 16 raised to y equals 4, because the meaning of logarithm is of its exponent. Therefore, y should be the exponent. So what should be, we have to express this in the same base. This is base 4. So we can only solve the equation if we will express 16 as base 4. And we know that 16 is 4 times 4. So therefore, it's equivalent to 4 squared times y equals 4. And if you don't have an exponent, it's understood that the exponent is 1. So therefore, 2y equals 1. And we will divide the equation by 2, and y is equivalent to 1/2. Alright, now let's go to number 4. So to change this to an exponential form, that's 2 raised to y is equivalent to 1/8. Alright, now this is a fraction. You might be thinking, how do I express this into exponential form when it's a fraction? Now remember, 8 is 2 times 2 times 2. Alright, so therefore, this is the same as writing 2 raised to y is equal to 2 raised to 3. Alright, but they are not, the base are still not the same. The base of this is 1/2. The base of this is 2. So we need to reciprocate this one. It's by virtue of exponential form, this is the same as 2 raised to y is equal to 1/2 raised to 3. So basically, the base are not the same. In order for us to make the base the same, we can reciprocate. And to reciprocate that, we need to make the exponent negative. Okay, because it's a law of exponent that when you reciprocate exponential expressions, you need to change the sign of the exponent. So if it's in the numerator, it's negative. In the denominator, it becomes positive. So in the denominator is positive, in the numerator is negative. Because we reciprocated it, the exponent becomes negative. So therefore, y is equal to -3. So by principle, when you have simple expressions like this, and you want to solve them, the first thing you do is to change them into exponential form. And from there, use your algebraic strategies by making the bases equal if they're both exponential or whatever to solve for your value.